Good morning.
Good morning, sir.
Good morning. Any doubts? Today we see the most important concept, which is called threading, multi-threading or concurrency or multitasking. It is again 1000% important question. You will definitely face singleton 1000%, design pattern 1000%, DQ reusable cell with identifier 1000%. Okay, optionals 1000%. There are some gunshot questions, around 160 gunshot questions. I have that document. I will share that as well. Okay, what is that? Multi-threading. Yeah, coming to the concurrency, there are two things which we need to discuss. One is dispatch queues, another one is the operation queues. Concurrency or multitasking or multi-threading is running multiple tasks at the same point of time. At the same point of time. The process, the tasks or the execution happens in two different ways. One is synchronous way, another one is asynchronous way. Synchronous means continuous. If you start to, assume that there are three methods. If you want to execute them synchronously, first method will be executed. Once that is completed, then only the execution in the runtime system moves to second, then third, then fourth. Here what happens is, it task to T2 waits for T1 to complete, T3 waits for T1, T2 to be completed, T4 waits for T1, T2, T3 should be completed. Synchronous means serial, we can say. Synchronous means serial, one after another. Asynchronous means all together. Here, task 1 started at our second 1, time T1. Task 2 started after 2 seconds. Task 3 started after 3 seconds, or task 4 started after 5 seconds. The execution, how it happens is, whichever is all 4 tasks will be executed simultaneously. Task 2 will not wait for T1 to complete. Task 3 will not wait for T1 or T2 to complete. Task 4 will not wait for T1, T2, T3 to be completed. It executes sometime, and the execution system gives the resources will be shared among the tasks, and all tasks will be executed simultaneously. Simultaneously means at the same point of all 4 will be executed. Assume that there are 4 tasks Task 4 takes 1 second. Task 3 takes 2 seconds. Task 2 take 2 seconds. 4 takes 1 second. 3 takes 2 seconds. 2 takes 3 seconds. 1 takes 4 seconds. T1 takes 4 seconds. Assume that 4 takes 10 seconds. 3 takes 20 seconds. 2 takes 30 seconds. 1 takes 40 seconds. Here, when you are executing all these 4 tasks, actually the smaller task is task 4. Task 4 need not to wait for T1, T2, T3 to be completed because the T1 takes 40 plus 30 plus 20. It is 90 seconds to execute the 10 seconds task. It need not to wait for 90 seconds. When you execute this by using serial queue, what happens? T4 will be executed after 90 seconds only. First 40-second task, 30-second task, 20-second task. Finally, because we have started to execute this at the end. In case of asynchronous, what happens is even you start T1, T2, T3, T4. Since T4 is taking less time, that will be executed first. That will be executed first. Even T1 starts. T1 takes 40 seconds, right? First, it executes for 10 seconds and shares the resources to the T4 or T2 or T3. Basically, what I mean to say is all 4 will be executed simultaneously. In this case, you cannot guarantee the order of execution. Order of execution here, it is not guaranteed. Maybe T1 might be executed first, or T4 might be executed first, T3 might, T2 might. In this case, in case of synchronous, the order of execution is constant. The way you started execution, the way the method is given to the process, if T1 is given first, that will be executed, then T2, T3, T4. Synchronous and asynchronous. Okay, what is synchronous? By default, all our tasks run on one after another. By default, all our tasks run one after another. The upcoming task must wait for the previous task to be completed. This is what is synchronous. Very, very important. Synchronous. Asynchronous. Since the independent tasks are waiting for the previous task to be completed, asynchronous makes multiple tasks to be executed at the same point of time. Because all these for independent tasks. Why should T4, which takes 10 seconds to execute, to wait for 90 seconds to start execution? It is not required. So this is where the asynchronous comes into picture. The asynchronous or synchronous can, by default, everything is synchronous. By default, everything is synchronous in the sense. Let me show you here. I'm having, let me take 2 functions for IM 1 to 100. For I'm printing F1 function 1 I. This is 1 to 1000, 1 to 10. Here 1 to 1000. This is F2. Let me make this as code snippet. Extracting. Right click, jump to definition, show code snippet, refactor, extract a method. I can mark this as F1. I'm just showing you how to extract a method. Refactor, extract a method. This is F2. F1, F2. There are 2 methods only. Okay. You can use the shortcut. That is what I have used here. Shortcuts I have used to extract some kind of code and make that as a method. Even this is not required. File private, which we are generally not using, but by default they are using it. This is F1. This is F2. Run it. Actually, F2 actually takes 10 milliseconds only. 1 to 10, right? F1 takes 1000 milliseconds. Assume that 1000 times it needs to be iterated, right? Though it takes 10 seconds, it executes after executing 1000 only. After executing, after printing 1000 lines of code, then only the 10 lines executed, because it is serial. First, F1 is there. The control system, how it takes the execution system comes from PVD load 11, 12, line 12, 13, 14. Wherever it finds 14, that is given to the process execute F1, which is there on the line number 14, then line number 15, then line number 16. Once line number 14 is completed, then only it comes to the line number 15. Okay, though this is smaller task which is waiting for bigger task to be completed. Actually, this is independent. These two are independent. This is not depending on the F2 method is not depending on the outcome of the F1. So these two are two independent tasks, but still the independent tasks are executing with some delay. With some delay, not really with some delay. The independent task also waiting for other tasks to be other independent tasks to be completed. Why should it wait? We can execute all these two together. This is where the asynchronous comes into picture. The asynchronous can be achieved in two different ways. Asynchronous or concurrency, we can say. Concurrency or multitasking or multi-threading. All concept is same. Another one is serial way or synchronous. Synchronous or serial, one after another. Concurrency means executing multiple things together. Here, order, the predefined order. Predefined order in the sense, if the execution, if F1 starts first, then F2 starts, the time of the order of execution is first F1 completes, then only F2 completes. In this case, I'll also show you this as well. F1 starts and F2 starts. In this case, actually F2 takes a smaller time, right? So it might execute first, then F1 might execute. Here, we cannot predict the order. Here, we cannot predict the order. Okay, here, to achieve these two concepts, we are having dispatch queues and operation queues. Dispatch queues and operation queues. These are the two mechanisms. There is one more thing called threads. These are the three different mechanisms which we are having in iOS to deal with these cases. Synchronous and asynchronous. By default, everything is synchronous or serial. One after another will be executed. One after another will be executed. How to achieve the synchronous? Yeah, there are two queues actually. Concurrent queues. Concurrent means to execute it in a concurrent way, we use concurrent queues. Serial queue, to execute it in a serial way, we use serial. Here, by default, everything is serial. Why do we need serial queue again? By default, everything is serial. Then, why do we need to execute it on serial? Basically, there are two queues. One is serial queue and concurrent queue, like synchronous, asynchronous, serial, and concurrent queues. There are queues. What are those queues? ACRI serial queue, concurrent queues. To execute synchronously, we use serial queues. To execute concurrently, we use concurrent queues. Very simple. Serial queue to execute one after another, concurrent to execute all multiple together. The serial queue runs on main thread. Serial queue, or we can also say it as main thread. Concurrent queues are said as background threads. Concurrent queues are also known as background queues. Serial queue is known as main thread. Very, very important. What is main thread? Main threads are the serial queues. How to create also I'll show you. The main purpose of main thread is to perform UI related operation. UI related operations. The main purpose of concurrent queues or main queue, concurrent queues, multiple things here. The main purpose of concurrent queues is executing long running non-UI tasks. Long running non-UI tasks. Basically, main thread is dedicated for performing UI related operations. Everything I will show you in practical. Executing long running non-UI task. Non-UI task means downloading the data from the server, executing the network request, pulling some information from the API from server. Those are loading the more data from the core database. Okay, these things we perform. Actually, these two are non-related related to. These are not related to the UI. UI means whenever you are dealing with, you are displaying something on the user interface. Those are UI related operations. But here F1, F2 are simply printing on console though. So these two are not related to the UI. These can be performed on concurrent queues. On concurrent queues. I'll show you how to create that as well. Okay. This is clear, right? I'm just repeating. The order of execution happens in two different ways. One is synchronous way, another one is asynchronous way. Synchronous means one after another. Asynchronous means multiple together. To achieve this, we have two different queues. Synchronous queue, that is called serial queue. Concurrent queues, those are concurrency multi-threaded queues are concurrency queues. Serial queue. The serial queue is also known as main queue or main thread. Main queue or main thread. Concurrent queues also known as background threads. The multi-threading can be achieved in two different ways. One is by using dispatch queues, another one is operation queues. Third one is threads. Main thread, which is serial queue. Serial queue is basically dedicated for the performing UI related operations, whereas concurrent queues are dedicated for executing long running non-UI related stuff, non-UI related tasks. Okay, clear, right? Now I want to execute. I want to create these two are not related to the UI. So I want to create one concurrent queue and execute these two tasks, F1 and F2. Let's try that. Let me create my queue. Let concurrent queue. The concurrence or multi-threading can be achieved by using two-way flow, right? Dispatch queue, operation queue. Operation queues. Let me try it. First, I'm trying with the dispatch queues. Let me take you through the other documentation as well. If I have anything missed. Then we have networking. Web services. Web services is different. Threading we have here. Maybe go to object-based. Web services, skeleton protocols. Where is that threading which we have seen now, right? Web services, concurrency, multi-thread. Yeah, same concept again in the form of Objective-C. Concurrency is a process executing multiple tasks at the same point of time. Basically, till iPhone 5, there were only one core processor. After iPhone 5, they have launched multi-core processors, where 4-core processors, where the multi-threading can be achieved from iPhone 5 onwards. iPhone 5 onwards, the hardware support also need to execute multiple tasks. Okay, that is already it. Multi-core processors are introduced. The concurrency can be achieved in 3 different ways: dispatch queues, operation queues, and threads. You can see why operation, basically to utilize the resources, hardware and software resources effectively, and for better performance, we use the concurrency. GCD or Grand Central Dispatch. People ask GCD or dispatch queues. GCD and dispatch queues both are same. GCD is the most commonly used API to manage concurrent code and execute operations asynchronously. Or the Unix level of system, GCD provides queues task, low level API. GCD is the low level API. Dispatch queues are low level. What is queue? Queue means a queue which follows first in, first out. Whoever first starts, they will be executed first. They will come out first. By default, it is synchronous. Dispatch queues are basically, the queues are classified into 2 different things. One is serial queue, another is concurrent queues. Serial queue is the main queue or main thread. By default, everything is here. This is also main thread. You can also see thread is main thread. I am on main thread. By default, it is on main thread. If you want to execute some tasks to be on concurrent queues, you can modify that. Okay, I am on main thread. By default, everything is on main thread. Even non-related operations also performed on main thread. If you perform non-UI related stuff on main thread, there is no issue. But if you perform UI related stuff on concurrent thread, then there is issue. I'll show you that as well. Serial queue, executing one after another, each one task at a time. When you choose to create queues as serial queue, the queue can only execute one task at a time. Okay, all queues one after another. Okay, the managing shared resources, you can read this. Advantages of serial queues: guaranteed serialized access to shared resources. If T1 starts first, the T1 will be executed completion execute, then only T2 starts. Means once T1 started, the complete resources are given to the T1 only. And avoids the race condition. Race condition means here T1, T2 will not fight for the processor, because we are by default we have specified execute after T1 only. T2 you execute after T1 only. So there is no risk and there is no fighting between the tasks. The order of execution is predictable. The order of execution is predictable. Also, we can create n number of serial queues. We can create multiple serial queues if you want to execute multiple things together on main thread. But there is one default thread that you can use for UI operations. If you want multiple main threads, multiple serial queues also, we can create. By default, there is one. Concurrent queues. We know what is concurrency. Executing multiple tasks parallel. The order starts in which they added to the queue. If T1, T2, T3, 4 are added to the queue in T1 first, F1 first, then F2 first we have added, right? Thus, execution starts first F1 and F2, but execution completion order we cannot predict. If this is a smaller task, will be executed first. Larger task might execute at the end. Yeah, queues. One serial queue and 4 concurrent queues. Now concurrent queues are increased in latest system. Concurrent queues are increased. Okay, same concurrent queue, but based on the priority, there are multiple queues. Here only one serial queue by default we are having. The priority is different. We are having different priorities in Swift now. Okay. Here the complete structure of queues. Dispatch queues are classified into 2 categories: serial queue and concurrent queues. The task follow first in first out order, starting with the same order. The task represented as a block of code. Here function we can give as a task, or block of code we can give to 2 queues. This queue also takes a block of code or means a closure or block of code or function. This is also same thing. Only one task to be executed at the same point of time. Serialized access to the shared resources. And no guarantee how many tasks are being executed at a time. No guarantee about the execution time. No guarantee about order of execution. Even if it takes 10 seconds, might take 40 seconds because it needs to be completed sometime other tasks, or it executes multiple tasks together, right? T1, T2, T3, T4 are given at the same point in time. Even though T4 takes 10 seconds, it might take 20 or 15 seconds to start because T1, T2, T3 were running already. How to create a serial queue? This is the syntax of Objective-C, but in Swift it is different. Creating concurrent queues with different priorities. Creating our own queues we can create. How to execute this? This is how we can execute it. We see that programmatically. How to create the code snippet for these two, and operation queues. This is everything about GCD or dispatch queues. How the operation queues works. GCD is a low-level API that enables developers to execute tasks concurrently. Operation queues, on the other hand, are high-level abstraction of the queue model, and it is built in on top of GCD. Here, operation queues are wrapper around the GCD. Means they have added some additional features on GCD only. That means you can execute tasks concurrently like GCD, but in an object-oriented fashion. GCD is low-level C-based API. Actually, it is dependent on the C-level API, but NS operations are completely object-oriented fashion. Unlike GCD, they don't conform to first in first order. Basically, operation queues are highly asynchronous. Highly asynchronous. NS operation queues allows you to cancel, resume, restart the operations. Very, very important. Here, it allows you to cancel the operation, resume the operation, restart the operation. Whereas in GCD, there is no way to cancel the function, cancel the operation execution once it is given to the queue. We can also set the completion handlers. We can also identify when the task is completed. We can also set the dependencies between two tasks. Difference between dispatch queues and operation queues are very, very important. Again, 1000% question. Difference between GCD or dispatch queues versus operation queues, 1000% question. GCD is a low-level API, whereas operation queues or NS operation queues are high level API which are wrapper around the GCD. Okay. GCD is synchronous and asynchronous, whereas operation queues are highly asynchronous. In GCD or dispatch queues, once the operation is started, you cannot stop it. Whereas in operation queues, you can start it, stop it, cancel it, resume it. In GCD, you cannot set the dependencies, whereas in operation queues, you can set the dependencies. In GCD, you cannot have the completion handlers, whereas in operation queues, you can have the completion handlers. Once the completion is, once the task is completed, you can get the you can get notified. These are the 4 or 5 differences you need to tell to the interviewer. 1000% question. On GCD, we'll at least face 2 to 3 questions. NS operation and NS operation queues, we see that through programmatically. They can add the dependencies. Dependency means if T1 result, T1 outcome is required to the T2, we cannot perform the concurrent operations. Then we need to perform the synchronous operation only, because T1 should be completed. Here see, P0 is there. P1 is depending on the P0 to be completed. Once you complete P0, the result is required to the P1. P1 result is required to the P2. This is the dependency, how we can add. We'll see that programmatically. We can cancel the operation. This is how the NS operation queue look like. Anyways, we see that programmatically. This is how we add the dependency and canceling the operations. Most important.